A nanosecond, a billionth of a second. That's all we're talking about. If you somehow found yourself on the surface of the sun for just that fraction of time, what would happen? Let's get straight to the point. At the very instant you arrive on the sun's surface, the temperature surrounding you is about 5,500 degrees Celsius, hotter than molten lava, hotter than any fire that has ever burned on Earth. But heat is the least of your worries. Before your body even has time to register the scorching environment, something far worse happens. The sun isn't just hot. It's a chaotic nuclear hellstorm, constantly blasting out intense radiation, magnetic fields, and high-energy particles. In a nanosecond, light will have traveled about 30 centimeters, roughly the length of a ruler. But the light reaching you isn't just ordinary light. It's an unrelenting flood of gamma rays, X-rays, and extreme ultraviolet radiation. These aren't just harmful. They are lethal at a level beyond comprehension. In less time than it takes for a nerve impulse to fire, the radiation would start tearing apart DNA, cell membranes, and even the molecular bonds holding your body together. You wouldn't just be burned, you'd be vaporized at the atomic level. And then there's the pressure. The sun's surface isn't solid. It's a seething, convective ocean of plasma, ionized gas where hydrogen atoms are smashed together at millions of degrees, fusing into helium and releasing unimaginable amounts of energy. If you somehow maintained a physical form for even a fraction of that nanosecond, you'd be thrown apart by intense solar winds and magnetic storms, your particles merging with the chaotic plasma before even the concept of pain could register in your brain. But let's say, hypothetically, that you were teleported back to safety exactly 1 nanosecond later, before you were fully vaporized. Would you survive? Not a chance. In fact, you'd be in worse shape than if you had just disappeared entirely. The radiation exposure would have been so extreme that every cell in your body would be irreversibly damaged. The atoms in your body would carry so much stored energy that you'd set fire to everything around you the moment you returned. You wouldn't just be dead, you'd be a walking, short-lived nuclear reaction. And we haven't even talked about gravity. The sun's gravitational pull is about 28 times stronger than Earth's, meaning if you were somehow falling into it, you'd be accelerating to hundreds of thousands of miles per hour before you even got close. Time dilation at these extreme speeds means your perception of time would be stretched, but it wouldn't matter. You wouldn't be conscious long enough to notice. But what if we placed you just above the surface, in the sun's upper atmosphere, rather than directly on it? Would that help? Not at all. The sun's corona, or outermost layer, is actually hotter than its surface, reaching temperatures of 1 to 2 million degrees Celsius due to intense magnetic activity. Even at a safe distance of thousands of kilometers, the radiation alone would annihilate any organic matter instantly. So, could you survive a nanosecond on the sun? Not a chance. Not even close. In fact, a nanosecond is far too long. The universe simply doesn't allow for something as fragile as a human to exist in an environment like that. Not even for the briefest fraction of time. Your atoms would be scattered into the solar plasma before your brain could even register the thought of regret. The sun may be the giver of life from a safe 93 million miles away, but up close, it is nothing but destruction